You might think your Wi-Fi comes from space, but 99% of the internet is actually sitting at the bottom of the ocean. Every time you send a message, watch a video, or load a website, you probably imagine satellites doing all the work. But that's not what really happens. Almost everything you do online travels through something far more physical, far more fragile, and far more fascinating. Thin strands of glass, lying silently across the ocean floor. This is the real internet. And today, I'm explaining it layer by layer, starting with the fiber read. At the very center of the entire global internet is something almost unbelievably small. A strand of glass. Not thick, not heavy, not complex looking. Just glass, about the width of a human hair. But inside that tiny strand, data moves at the speed of light. Literally, this is called optic, old fiber, instead of electricity, like old copper cables used. Modern internet cables send light signals. Those signals bounce inside the glass using something called total internal reflection. Think of it like a beam of light trapped inside a tunnel, bouncing perfectly from wall to wall, never escaping. That's how your data travels thousands of kilometers. With leaking out. Surrounding that glass core is another layer called cladding. Its job is simple. Keep the light trapped inside. Then comes protective coatings. Soft, flexible materials that prevent the fiber from cracking or bending too sharply. Because even though this cable powers the modern world, it is still fragile. In the past, cables were made of copper. Heavy, slow, and limited. But today, one fiber pair can carry terabits of data per second. That's millions of videos, moving at once. And modern cables don't just have one fiber. They have dozens. Some SOV, 800. Now here's where things get serious. Because that tiny glass strand has to survive the ocean. So around that delicate fiber, engineers build layers, each one with a purpose. First, a gel-like substance, often petroleum-based, fills the space around the fibers. It blocks water, because if water gets in, the signal dies. Then comes a copper layer, not for strength, but for power. Next is steel, thick, galvanized steel wires, wrapped tightly around the cable. This is the armor, and depending on where the cable is placed, that armor changes. In the deep ocean, where nothing really touches the cable, it's surprisingly thin, lightweight, flexible, because pressure is high, but there's little physical disturbance. But near the shore, everything changes. Ships drop anchors. Fishing equipment drags across the seabed. So cables near coastlines become heavily armored. Thicker, stronger, sometimes several times larger than deep-sea sections. All of this, just to protect something as fragile as glass. And somehow, it works. These cables survive for decades, under crushing pressure and constant exposure to salt water. Now here's something most people don't know. These cables don't just carry data. They carry power too. Because every 60 to 100 kilometers, there's a problem. Light weakens over distance. Even inside perfect glass, it slowly fades. So engineers place devices along the cable called repeaters. These are like signal boosters. They take the weakened light, amplify it, and send it forward again. But those repeaters need energy. And there's no battery you can replace in the middle of the ocean. So power is sent through the cable itself. High-voltage DC electricity travels along a copper layer inside the cable, feeding every repeater along the way. Silently, continuously. Some cables stretch thousands of kilometers, which means hundreds of repeaters, all powered through a single line. And then there are branching units. These are like underwater intersections. They allow one main cable to split and connect to different countries or regions. So instead of one straight line, you get a network. A hidden web beneath the ocean. Let's talk about threats and technical resilience. Now you might be wondering, what could possibly damage something built this carefully? The answer is more than you'd expect. Ships, anchors, fishing nets, even natural events like earthquakes or underwater landslides. And yes, even sharks. There have been real cases of sharks biting cables. But modern designs have reduced that risk significantly. Still, damage happens. So how do engineers find a break? In thousands of kilometers of cable, they use light itself, a technique called optical backscatter. They send a signal down the cable and measure how it reflects back. From that reflection, they can pinpoint the exact location of a break, sometimes within meters. Then comes the response. Specialized ships, cable repair vessels, are deployed in the middle of the ocean. They locate the cable, pull it up from the seabed, cut the damaged section, and splice it back together, all while maintaining precision. In unpredictable conditions, it's one of the most complex repair operations on Earth. And it happens faster than you'd expect, because the internet can't wait. Eventually, every undersea cable reaches land, at a place called a landing station. From here, the signal transitions from ocean cables to terrestrial fiber networks. And that's when your data enters the part of the internet you're more familiar with. Data centers, service, cloud systems. But even here, redundancy matters, because no system is perfect. So modern networks combine submarine cables with satellite systems, not as the main path, but as backup. If one route fails, another takes over. And all of this happens in milliseconds. So when you click a link, your request might travel across continents, dive into the ocean, cross thousands of kilometers of seabed, resurface in an other country, and return back to you almost instantly. I know the internet feels invisible, but it's not. It's physical, it's engineered, it's fragile, and incredibly powerful at the same time. Every message you send, every video you watch, every click you make depends on glass threads lying quietly beneath the ocean. And once you see that, the internet stops feeling abstract. It becomes something real, something built, something you can finally understand. And so if you want to understand what actually travels through these cables, the difference between data in motion and data at rest, watch my memory versus storage video next. Because once you understand that, you'll see the internet in a completely different way.